Good morning, everyone. Good morning, good morning, good morning. I'm glad to have y'all with me. Today we're starting on package week 6, day 1. It would say page 3 of 36. Once again, week 6, day 1, page 3 of 36 is where we're starting at today. Before we get started, I want everyone to make sure that they have 2 coins with them, please. Whether you have a penny, dime, nickel, or quarter. Make sure you have 2 of them and make sure they are not the same. Once again, for all those that's just joining, I said good morning. Glad to have you with us this morning. Before we get started, I want everyone to make sure they have 2 coins with them. It could be one quarter, 1 penny, 1 dime, 1 nickel. It doesn't matter, but it cannot be 2 of the same. Okay? So please go ahead and get those quarters those coins before we get started, please. Try to make today a little bit fun and go through one of the exercises they have where we're going to be flipping coins, using that to determine the probability. Once everyone has gathered their 2 coins, please give me a thumb up in the comment section so then we can move forward. Remember, it doesn't matter what coins they are, as long as it's not 2 of the same. If you do not have this week 6 package with you, that is fine. Then I just need you to write it down on paper and make sure I receive your picture. Give you guys about 1 more minute. Once again, I want to make sure everyone can get 2 coins right quick. 2 coins. It doesn't matter if it's a quarter, nickel, dime, or penny, as long as it's not 2 of the same. Okay? Make sure you have 2 coins with you, please. That is what I'm asking for at this moment. Also, right quick before we get started, if you look down at my pinned comment section, it tells you that we're on week 6, day 1 package. And then after the dots, it says enroll DCPS.dc.gov. Remember, we spoke about this last week where I need you guys to go ahead and enroll. I need yourself as well as with your parents to sit down at a computer, go to this here website, and type it in so you guys can go ahead and get enrolled in for school next year, okay? Nothing could be done via paper, so I need you to please, at your earliest convenience, okay? If you already done it, I appreciate that. Good job, okay? But those who have not, with your parents, please go to that website at the bottom, enroll DCPCS.dc.gov, and get enrolled into Charles Hart, okay? I know some of you say you may not be attending Hart next year. That is fine. But this here paper still needs to be filled out. Okay? It still needs to be filled out. So once again, Miss McDuffie and Mr. Kennedy, Miss Strickland will be sending out a list of students who have done this. I will be giving them extra credit. Alright, so let's get started. Okay. Objective. By the end of today's learning, I will calculate the probability of an event when the outcomes in the sample space are not equally likely, and explain why results from repeating the experiment may not exactly match the expected probability for an event. Okay. So now the opening says to give you guys 5 minutes. Directions. Answer each question in the space provided. Okay. So I want you guys, if you can read what I have here, all 3 of these questions, I want you to answer those questions, okay? And I'm going to give you guys, it's 10:05. I'm going to give you like 5 minutes to do that on your own, okay? And then we're going to go over it together, All right. So once again, right now you're answering these 3 questions under the open exercise. Okay. Good. Good morning, good morning, good morning to everyone who just now recently joined us. Right now, the students are answering these first 3 questions. Then we're going to discuss it in the comment section before we move forward. Also, for my students who just joined, I need you to make sure you have 2 coins with you. They cannot be 2 of the same. You can have 1 quarter, 1 nickel, 1 dime, 1 penny. But make sure you have 2 and make sure they are not the same. Got about 1 more minute. 1 more minute. That is 1 over 10, Demaya. 1 over 10. Good morning, Miss Proctor. All right, so let's look at number 1. Let's look at number 1 together. Number 1 reads, if the weather forecast called for a 20% chance of light rain tomorrow, will you say that it is likely to rain tomorrow? Why or why not? Let me read that one more time, okay? If the weather forecast called for a 20% chance of light rain tomorrow, would you say that it is likely to rain tomorrow? Why or why not? So in the comment section, okay, I just want you to briefly give me your answer, okay? Just say why or why not, comma, and then explain your answer. You don't have to give me a lot. Just give me a small, complete sentence, okay? Or if anyone would like to join the live to get extra credit, I will allow you to do that, okay? So I had Darian said no because the probable is low. I guess he meant probability. You Love More said no because of how low the percent is. Okay. Elizabeth said no because the percent is low. Okay. Okay, so all those are pretty much accurate. Genesis says, I say it's not likely because it's lower than a 50% chance, so that makes it unlikely. Okay, I like those answers. Good answers so far. Let's move on to number 2 then. If the probability of a tornado tomorrow is 1 over 10, that's what that fraction says, 1 over 10. Would you say that there will likely to be a tornado tomorrow? Why or why not? If the probability of a tornado today is 1 over 10, would you say that there would be that there will likely be a tornado today? Why or why not? So it gives you a fraction of 1 over 10. 1 over 10. So before we answer that question right quick, can someone tell me 1 over 10 will be what as a percent? 1 over 10 would be what as a percent? Can someone answer that question for me, please, in the comment section? DeMarcus said 10%. Elizabeth said 10%. Okay, that is correct. Darian said 10%. 10% it is. Good job, ladies and gentlemen. Good job, Ms. Blyther. All right, so let's go back then, okay? If the probability of tornado is 1 over 10, would you say that there likely be a tornado today? Why or why not? No, because there's still a 9% chance it won't be a tornado. Good job. Who is that? Big Daddy Green, 34. Yolami said 10%. Cool Panda. Okay. All right, so we're going to move on along. Number three. So in the comment section right now, I'm only looking for answers for number 3. If the probability of snow this week is 0.85, would you say that it's likely to snow this week? Why or why not? We're on question number 3. If the probability of snow this week is 0.85, would you say that it's likely to snow this week? Why or why not? Right now, we're only answering question number 3 in the comment section. Okay, got a couple of yeses. Yes, because it's higher than 50%. No, because it's 0 point. Yes, almost to 100. I'm unsure. Okay. So the correct answer will be yes, okay? Because please remember, 0.85 is a decimal, right? If I convert that decimal to a percent, it's going to be 85%. Okay? Aaliyah, we're on package for week 6, day 1. Okay? Page 3 of 36. If you don't have the package for week 6, okay, then just follow along with what we have on the screen, all right? So to be, yes, because it is high, that is correct. No, because it's a decimal. So Darian, although it is a decimal, if you convert that decimal to a percent, 0.85 is going to convert to 85%, okay? It's going to convert to 85%. And 85% is pretty high. Okay? Any questions? Let me get thumbs up in the comment section if you guys are good. We can move on to the next page. Let me get a thumbs up in the comment section if you guys are good, and then we can move on to the next page. Good morning, Miss Matthews. Thank you, Tater Tot. Okay, so I'm getting thumbs up. That means we're good. Okay. So let's go on to the next page. All right, the next page, page 4 of 5. Page 4 of 5. There's nothing to do on this page. I'm just going to read something very important to you right quick. All right. Experimenting for probability. Definition. Experiment in probability is determined from the results of a chance of experiment. Example. Brian flipped a coin 10 times and recorded the results. The coin landed on heads 3 times and tails 7 times. The experimental probability of a coin landing on heads from this chance is 3/10. Okay? Remember, probability is just pretty much you answering the question, what out of what? This how many chances out of this how many attempts. Theoretical probability is the expected probability of a situation given what we know to be true. Okay? Brian has a coin and wants to know what is the probability of a coin landing on heads. Alright? There are 2 equal sides of a coin. So the probability of the coin landing on heads is 1/2. Alright? So it says today we will conduct a chance experiment and compare our results to the theoretical probability. Alright? You would need 2 different coins. Penny, quarter, dime, or nickel. It doesn't matter. That's what we talked about earlier. Okay? That's what we spoke about earlier. Alright? So right now, we're going to go ahead and go over to page 5. Alright? We're going to go over to page 5. And you guys are going to do this on your own. Okay? You're going to do it on your own, and then we're going to discuss it. For the first 2 rounds, use one of your coins. So for myself, I have a quarter here. Alright? I have a quarter right here for myself. Here's my quarter. Alright? It said flip your coin 10 times and record the outcomes in the table. So over here, hold on, give me 1 second, I'm sorry. Trying to get the light off the screen. Okay, so over here in the column section, you're going to put down in this here thing. So when I flip my quarter the first time, if it land on heads, I'm going to write an H. If it land on tails, I'm going to write a T. And you're going to do that 10 times real fast, real quick. So right now my clock says 10:18. I'm going to give you guys till 10:20 to do that. Okay? You're going to flip your coin 10 times. Record what occurs every time in this here table chart here for me, please. Then we're going to go back and answer these questions 1 through 4. Good morning, Sean. Glad to have you with us, sir. So for those who are just joining, we're on package week 6, day 1, page 5 of 36. Okay? And we are doing round 1 of the coin toss. Round 1 of the coin toss. So I'm about to remove my paper so I can do this myself also, okay? It's 10:19. I'm going to give you guys, I said to 10:20, but I'm going to move it to 10:21, okay? Let's get started. I already done mine. I'm going to flip it over because I want you guys to see the answers, what I have. All right, 30 more seconds. 30 more seconds. Okay, cool. Now, here we go. I wish I wouldn't have wrote the answers. Here's what I just got for mine. Okay? It said, what is your total number of heads? Okay? Out of the 10 times I flipped the coin, I got heads 5 times, and I got tails 5 times. It said, did you get all of the different possible outcomes in your 10 flips? Did you get heads at least once and tails at least once? My answer was yes. What fraction of your 10 flips landed on heads? So right here, remember I got a total of 10. Okay, remember your denominator represents how many times you actually did it. I flipped the coin 10 times, okay? That is how I came up with this 10 right here. So out of 10 times, I landed on head 5 times. Please remember, okay? I need this question to be answered in the comment section, okay? Whenever you're submitting your answer as a fraction, before you do that, you must always make sure your fraction has been what? Answers in the comment section. Whenever you are submitting your answer as a fraction, before you finish, you need to always make sure your fraction has been what? What do you do to your fraction before you submit it? Good job, It's Money 07. She said simplify. That is correct. That is correct. Good job. Good job, everyone. Simplify. So, as you can see here, right? I had 5 out of 10, correct? And did I submit as 5 out of 10? No. 5 out of 10 reduces to 1/2. So, my answer would be 1/2. My answer would be 1/2. All right. Good job. Good job. Move on down to round 2, okay? Move on down to round 2. Now for round 2, I want you to use the second other coin that you picked up. For myself here, I'm going to use a nickel this time, okay? First round I had a quarter. Second round I'm going to use a nickel, okay? So right now we're doing round 2. We're doing round 2. Let's get started. I have 1023. I'm going to give you guys till 1025. Got about 35, 45 more seconds. We're doing round 2. Okay, boom, here we go. Round 2. I have recorded my outcomes here. All right, flip your coin 10 more times and record your outcomes in the table. So to the right here, I have my outcomes. Okay, I flip tails, 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 head, tails, head, tails, tails, head, tails. Okay, that is what I have here. All right, so question number 2. From this round, what is your total number of heads? I had 3 heads and 7 tails. Okay. Now, for question number 3, please make sure you're reading correctly. It says from both rounds 1 and 2, what is your total number of heads? So if I had 5 in round 1, 3 in round 2, I had a total of 8. Okay? In round 1, I had 5 tails. In round 2, I had 7 tails. So that gives me a total of 12. Okay? So now, question number 4 says, what fraction of your flips landed on heads? Okay? What fraction of your 20 flips landed on heads? So that is a combination of round 1, which was 10 flips, and round 2, which was another 10 flips. So that's where they get the total of 20 from. So we know my denominator is going to be what? 20. Okay? Now when I combine round 1 of 5 plus 3 from round 2, my numerator becomes 8. Because out of the total of 20 flips, I had a total of 8 that landed on heads. Okay? So now, I have a fraction of 8 over 20. Can I submit my answer as 8 over 20? It's money, I already said it. Simplify 8 over 20. That is correct. So what is 8 over 20 simplified? That is what I want to know right now. Can someone tell me what is 8 over 20 simplified? What is 8 over 20 simplified is what I want to know. Two over 5. 2 over 5 is correct because both the 8 and the 20 can be reduced or simplified by 4. Okay? So if 4 is the greatest common factor of those two, right? Then you're going to divide them both by 4. And 8 divided by 4 is 2. 20 divided by 4 is 5. Okay? So that is how we will come up with 2 over 5. That is how we come up with 2 over 5. They both can be reduced by 4. Now, that was page 5, right? If you look on the back of page 5, you have page 6, which is the same thing. Okay? Page 5 and page 6 is the same exact thing, okay? So I want you to make sure you complete page 6. That's going to be a part of your homework. Okay? Page 6 is a part of your homework. Moving on to page 7. Okay? We're moving on to page 7. And we're just going to read this right quick together. Okay? That is what we're going to do. It says, these are reflection questions. Does each coin have the same sample space? If so, do they have the same probabilities for each outcome, heads or tails, as a result? We already know that is true. We already know that that much is true. Okay? So I know that the sample space for any monetary coin in this country is either heads or tails. Because they are two equal sides, each outcome has the 50% chance, a 50% probability of occurring. Okay? So in this blank right here, you're going to go with 50%. In that first blank next to the pencil here, you're going to write has the 50% probability of occurring. All right. Question number 2. For each coin, what is the theoretical probability that it lands on heads? Explain or show your reasoning. Hint, you may want to refer back to the beginning of today's learning section. So we're not going to worry about number 2. I want you to put an X over number 2. That's kind of, it's relevant, but it's not as important. So just put an X over number 2. And then now let's read number 3 together also though. It said Noah flipped his coins 10 times. It never landed on heads. How might you explain why this happened? Noah only conducted his experiment 10 times. We can expect that if he continued to repeat his experiment and flip the coin more times, it would eventually land on heads. In fact, if he flipped his coin thousands of times, the probability likely started to get closer to the expected theoretical probability. So remember, there's two different probabilities here, okay? There's two different ones. Theoretically represents what we expect should happen. For example, when we're flipping a coin, we know for a fact it's going to either land on heads or tails, okay? So theoretically is representing what we expect or what we know to happen. The definition was theoretical probability is the expected probability of a situation given what we know to be true. Okay? We know a coin has either heads or tails on it. So that is a theoretical probability. Okay? And then don't forget we have experimental probability, which is determined from the results of a chance experiment. Okay? So experiment in probability is what occurs once you actually do it. It's experiment, so you do it. Okay? And then you write down what is the probability after you have experimented it. Theoretically, to me, it's pretty much more what you think or what you know is going to happen before you do the experiment. Okay? If that makes sense. Okay? That is very important, though. So, back on page 4, I want you to please go back on page 4. All right? And just make sure that you put stars by those two definitions there. Those are very important that you remember those definitions. Okay? You have experimental probability, and then you have theoretical probability. Okay? Those are very important. Please do not forget those. Those are very, very important. All right? That was page 7. Flip on page 7. You're going to be on page 8 now. You're going to be on page 8. And I know we're kind of moving a little fast this morning, but I do feel that with the students I know I have here on this live, you guys are pretty smart. And the things that I'm skipping, you want to have no problem going back doing them on your own. If you do have any questions, concerns, or need additional help, just please reach out to myself or Miss Felice or Mr. Winley, and we will help you guys out. All right, we're on page 8 now. Okay? It said, imagine for a moment the following situation. 2 of your classmates, Laura and Carla, are contestants on a quiz show called Picking Green. There are 2 bags in front of you, bag A and bag B. Each bag contains green and white chips. They are told that one of the bags have exactly the same number of green chips as white chips, but they are told nothing about the ratio of green to white chips in the other bag. Alright, so Laura and Carla decided to conduct research by doing an experiment separately. Okay, notice it said conduct research by doing an experiment separately. This is what they are doing, correct? That's what makes it experimental, okay? Not theoretically. Each girl picked chips from the bag and recorded their results without looking inside the bag. Below are their results. So if you look here, right, at this first chart to the left, it has Laura results. Bag A, bag B. In bag A, she had 35 number of green chips picked. In bag B, she had a total of 15 white chips that she picked. Okay. In bag B, she had a total of 22 green chips that she picked. And in bag B, she had a total of 28 white chips that was picked. Okay. And then to the right, we have recorded the results for Carla. All right. Now, let's go down to number 1. It says, if all you know about the bags are the results from Laura research, which bag would you select for the game? Explain. Now, they already have the answers here. Why, I'm not quite sure, but we're still going to discuss it, okay? So they said I would choose bag A because Laura results showed that she picked a lot more green chips than white chips from bag A. So, looking at Laura, okay, let's go back to the question one more time. If all you know about the bags are the results from Laura research, so that means right now we're only looking at this left side at Laura, okay? Which bag would you select from the game and explain? So they're saying they would choose bag A because she picked a lot more green chips, which is 35, than white chips. So it's a difference of 20. She picked 20 more green chips than she did white chips. Okay? And she picked 28 more white chips than she did green in bag B. So they're saying they would go with bag A. Alright? In order to win, I want to pick the bag that I think has the most green chips. So, just by looking at these charts and looking at the results, do you agree with them choosing bag A? I'd like to know your opinion in the comment section. Do you agree with them picking bag A, and why? Please tell me in the comment section, please. So, Demaya, you just said bag A, but you got to give me a little bit more information, young lady. Why would you choose bag A? Elizabeth said, I agree with bag A because there are enough chips for everyone to pick. Then bag B. Samuel said, I be the bag. Not quite sure what you're trying to say, Samuel. Guess you're saying you would pick bag B, okay. Demaya said, I ain't say bag A. Okay, I'm sorry, Demaya. So whichever bag you choose is your choice, but I want to know why. Is bag B? Is B bag because have what? Bag A because it is a lot. So think back to what everything we did this morning, okay? When it comes to the percentages and things of that nature, okay? So what I want you guys to do before you guys continue to keep answering me, I want you to write down the fraction for bag A and write down the fraction for bag B out to the side here. Okay? Write those fractions down for me, please. What is the fraction for bag A and the fraction for bag B? Now, in your fraction, I only want you to represent the number of green chips picked. Okay? Give me your fraction for bag A for the number of green chips that was picked. So Darian says 7/3. So for bag A, correct? For bag A, if I want a fraction for the number of green chips that picked, right? I'm not quite sure how you came up with 7/3, Darian. Elizabeth said 1/11. Samuel said 7/3. Retard said I'm confused. Okay. So if I'm asking for a fraction to represent the number of green chips picked from bag A, only from bag A, Okay? Only from bag A right now. If the number of green chips picked was 35, 35 is going to represent your numerator. Now, there's a total. For bag A, you got 35 plus 15, which is going to be 50. So you're going to have 35 over 50. There's your fraction. 35 over 50. Because there was a total of 35 green chips picked. Okay? Out of a total of 50. 35 and 15 gives you 50. Okay? That is what I meant when I said give me a fraction to represent the number of green chips picked from bag A. All the way across here represents bag A. I don't have nothing to do with bag B right now. I'm only referring to bag A. Alright? So now if I have a fraction of 35 over 50, can I leave that as 35 over 50? That is what I want to know. Can I leave that as 35 over 50 for bag A? So Leak says 7 over 10. 7 over 10 would be correct. 7 over 10 would be correct because you can simplify both the numerator and the denominator by 5. Okay? 35 divided by 5 will give me 7. 50 divided by 5 will give me 10. Okay? So now, right quick, give me the fraction for bag B, representing green chips. Give me the fraction representing bag B for the number of green chips picked. We have a total of 22 green chips that was picked out of a total of 22, and 28 is going to give me 50 again. So you're going to have 22 over 50. And yes, that can be reduced or simplified. So 22 over 50 reduces to what? What does 22 over 50 reduces to? That is what I want to know. Can anyone tell me before we end this lesson today? Well, we do know they both are even. Genesis said 11 over 25. Good job, Genesis. 11 over 25 is correct. They're both even numbers that can be divided by 2. So 22 divided by 2 gives me 11. 50 divided by 2 gives me 25. Okay? And 11 over 25 cannot be reduced or simplified anymore. Okay? So that's pretty much all we have for today. I will make a post letting you guys know what is your homework. Okay? Please remember, as you look in the comment section where I have the website enroll.dcps.dc.gov. Everyone needs to go to that website and enroll into school for next year. Remember, even if you think or you know you will not be attending Hart, please, please, please go to the website, enroll. You need to sit down at a computer with yourself as well as with your parents or your guardian. Complete this here form. I was told it shouldn't take you guys no more than about 5 or 10 minutes. Okay? If you need any assistance with it, you can reach out to Miss McDuffie, Mr. Kennedy, Miss Strickland, or Mr. Canfield. They can help you guys walk through it. Okay? But I was told it shouldn't take you no more than about 5 to 10 minutes to do. All right? So we can know who's going to be attending the amazing Charles Hart Middle School next year. Mr. Kennedy and Miss McDuffie will be sending out lists of who has done it. I will be giving you guys extra credit for going in and doing what you're supposed to be doing. Like I said, look at my page later on today. It will let you know what you need to be completing for homework for tonight. If there's no questions, you guys may log off and have a nice day. I appreciate you guys logging in today. If you didn't tell your mothers Happy Mother's Day yesterday, please go see her now and apologize and make sure it gets done. Alright? Alright, Samuel. Are you going to call me Miss Taylor, Samuel? Okay, I got you. Alright, Sean, you have a nice day, sir.